A sports stadium has a T-shot cannon which is used to launch T-shots into the crowd. The purpose of this question is to determine whether a person sitting in a particular seat will ever receive a T-shot. A T-shot cannon is placed on a horizontal ground of a stadium playing area. A coordinate system is created such that the origin, O, is the point on the ground from where the T-shots are launched. In this coordinate system, X and Y represent the horizontal and vertical displacement from O and are measured in meters. Seat A1 is the nearest seat to the T-shot cannon. The coordinates of the front of the foot space for seat A1 are 30 and 2.1. Each seat behind seat A1 is 1 meter further from O horizontally and 0.5 meters higher than the seat in the row below it, as shown on the diagram. Seat A1 is in row 1. Let seat A and be the seat directly behind A1 in row N. AI, write down the coordinates of the front of the foot space of seat A5 to marks. So we need just coordinates of this point. And you can see that X coordinate becomes what? It's just 30 plus 1, 2, 3, 4 steps. And for each step plus 1. So it becomes 30 plus 4 times 1 and it's 34. And Y coordinate, it's what? 2.1 plus 4 times 0.5 and it's 4.1. And the next question, find in terms of N the coordinates of the front of the foot space of seat AN, 3 marks. So we need in general the coordinates of AN, and absolutely similarly you can notice that it's what? It's an arithmetic sequence, and using the formula UN is U1 plus N minus 1 multiplied by D, where D is the common difference. Here it becomes what? For X it's 30 plus the common difference is 1, so just multiplied by 1 multiplied by N minus 1. And Y coordinate is what? It's 2.1 plus 0.5 times N minus 1. You may simplify, but it's not necessary. The next, while in motion, the T-shot can be treated as a projectile. Let T be the time in seconds after a T-shot is launched. At any time T is greater than 0, the acceleration of the T-shot in meters per second squared is given by the vector. It means what? The second derivative of the displacement and its acceleration. And you can see that horizontal component of acceleration is 0 and vertical component is negative, and minus implies what? That y direction up is chosen as positive, and it's actually what? Usual free fall. 9.8 is what is acceleration due to gravity, and since what acceleration is constant, we can apply usual that formulas. You may know them from physics, for example. So the initial velocity in meters per second of the T-shot is given as 29.4 times cosine, and its horizontal component of the initial velocity and the vertical component of the initial velocity is what? 29.4 times sine, where theta is the angle to the ground at which the T-shot is launched, and theta is greater than 0 and less than 90 degrees. And it's quite clear because what? There is some vector of the initial velocity is theta, and you can see that horizontal component is the magnitude of u, and you may deduce that magnitude of the initial velocity is 29.4. Its horizontal component cosine is cosine, vertical is sine. And what is the question actually? BI, find an expression for the velocity at time t, 3 marks. And when acceleration is constant, we can just apply a formula. It's initial velocity plus acceleration times time. And them must be vectors. or you may integrate, because actually velocity, it's it's x dot y dot, it's the first derivative of the displacement and corresponding components, and to get it the first derivative from the second, you should do integration. So integrating this, you can constant, integrating this component, you get now negative 9.8 t plus constant, and applying the initial conditions, that initially velocity vector is equal to this, you can find c1, c2, and hence find the velocity vector, or just applying this for projectiles with constant acceleration, it becomes the initial velocity vector plus time multiplied by acceleration vector. The next BI, find an expression for the velocity at time t, done. It's BI, and the next hence shows that when the t-shot is launched vertically, the time for it to reach its maximum height is 3 seconds. And 3 marks. And you remember that at the highest point, vertical component is equal to 0. So equating the vertical component of the velocity, this to 0, we can find time required to reach the highest point. Here there is only vertical component, but it doesn't matter. It may be two-dimensional, but to find time required to reach the highest point, vertical component of velocity should be equal to 0. And since it is given that it is launched vertically, provided that theta is 90 degrees, or you may write 1 directly here, and it's 3 seconds exactly. Sine of 90 degrees is 1. The next, the displacement of the t-shot t seconds after it is launched is given by the vector equation. It is given, but it may be asked in general, and it can be easily deduced that displacement vector is ut plus at squared over 2, provided acceleration is constant. And position vector in general, it's a vector from origin at any moment of time. It's position vector of the initial point plus displacement. So it's not required here. And what is a question actually? C. Using the given answer to part BII, or otherwise find the maximum height reached by a t-shot when it is launched vertically, 2 marks. So substituting 3 seconds for t, we can find the y value gives us a vertical component of the displacement, and it's actually the greatest height. And actually here theta is 90 degrees, and there is vertical component only. But in general, you should, when it's two-dimensional motion, you should do absolutely the same. So substituting, and also again theta is 90, because motion is vertical only, y becomes 29.4 times 1 times t times, it means times 3, minus 4.9 times 3 squared, and it is equal to 44.1 meters. It was CDI. If there was no sitting and the T-shot was launched at an angle theta, show that the value of x when it would hit the ground is given by the expression. We should get this 166.4 sine cosine. We should get this. What does it mean? It means that it launched at some angle theta. It's angle between the initial velocity and the horizontal, and we need this distance. It's called range. So we need this x coordinate depending on angle of theta. And how to find that? You can find the time required to reach the highest point and the time required to reach this point. Due to symmetry, you can see that it will be 2 times larger, and to find this you should equate what? Vertical component of the velocity, which is what? 29.4 sine theta minus 9.8 t to be 0. So you can see that t is 29.4 sine over 9.8, and to reach this point we need times 2 times larger, and horizontal displacement this. So we substitute and get that x becomes 29.4 times cosine times t, but t is 2 times larger, so it's times 2 times 29.4 times sine, and divided by 9.8, and it is equal to this directly. Or at this point you can see that displacement is equal to 0. Not just displacement, sorry, vertical displacement is equal to 0. And where is the expression for the vertical displacement? Just y. And equating it to 0, you can see that t can be factored out, and you get 29.4. Let's rewrite above. You get that it becomes 29.4 sine minus 4.9 t is equal to 0. And the first root is 0. It's when it's at the starting point. And the second solution is 29.4 sine divided by 4.9, and it's time required to reach this point. And you can see that here, if we divide by 2, we get the same, this 4.9. And substituting again this t for this t, this expression for t, you get the same result, which is equal to this. So it's horizontal distance traveled depending on the angle of the between the initial velocity and the horizontal. And the next, hence find the maximum possible value for x if there was no sitting to block the path of the T-shot to max. So we need find the greatest possible value of this x. And the simplest way is, we know that sine or cosine have a range. They changes from -1 to 1, and we also know that 2 sine cosine is the sine of a double angle. So we can rewrite as 176.4, and if we multiply and divide by 2 and sine cosine, and this is sine of 2 theta, so it becomes 88.2 times sine of 2 theta, but sine or cosine, and it doesn't matter the argument, sine of 2 theta changes from -1 to 1 in general, and the maximum possible value when sine of 2 theta is 1. So x max, it's when sine is 1, and it's 88.2 meters. You may use another way to find the maximum possible value of this expression. And you can see that it's 1 when sine of 90 degrees, so maximum when theta is 45 degrees. The next, in order to calculate the seats in the stadium which can be reached by a T-shot, it is required to find the equation of the curve that forms the boundary of all the points that can be reached. This boundary is represented by the dashed curve in the following diagram, while the solid curves represent some of the possible trajectories for the T-shots. It is given that the boundary curve is the parabola y is x squared plus bx plus c with the vertex v on the y-axis. Using your answers to parts C and DII, or otherwise find the value of C, the value of B, the value of A, 1, 2, 3 marks. So, what is V? It's a trajectory when hence the maximum possible height when it is launched vertically, and it was 44.1, and it's the maximum possible horizontal distance traveled, and it's from the previous, it's 88.2, and it's a parabola, and we need the equation of this parabola, and it's very important that it's a vertex, and we know that axis of symmetry, and it's actually x coordinate over vertex is negative b over 2a. This formula is given in a data booklet, and since x is 0, we can conclude that b is 0. We let it be x of point v, or you may say axis of symmetry or something like that, or x coordinate over vertex. So b is 0. You can see that c is what? It's when x is 0, it's y-intercept. So y of 0 is c, so c is 44.1. And hence it becomes y is ax squared plus 44.1, and substituting 88.20, it's a point on our curve, we get the next that 0, or it's a root. 0 is 88.2 x a 88.2 squared plus 44.1. Hence a becomes what? Negative 44.1 divided by 88.2 squared, and you can notice that it's 1, we can reduce, it's 1, 2, and if we multiply by 5 to get integer, it becomes negative 5 divided by just 882, or you may write as decimal. So a is negative 5 over 882. And the last question, a spectator is sitting in seat A40 show that it is not possible for the spectator to ever get a t-shirt, 5 marks. So from our formula for AN, you can see that when A is 40, we get that coordinates become 30 plus 39 and 2.1, 2.1 plus 0.5 times 39, so A40 has coordinates 69 and 21.6, and this situation looks like this. So somewhere there is a 40, and to get a t-shirt we must be, or this point must be where? Must be on the curve. And since y coordinate is 21.6 and this point A40 must be on the curve, and curve is what? Negative 5 over 882 x squared plus 44.1. So substituting 21.6 for y, we can find the required x coordinate to be on the curve, and we will just compare with 69. X squared plus 44.1 is equal to 21.6, and it's can be solved easily. Just 44.1 to the right with minus, it will be negative, minus is cancelled, then multiplied by 882, divide by 5, and then square root, and definitely we need positive value only, and x becomes 63. And since 63, or as 63 is less than 69, it means what? It means that coordinates of A40 are not on the curve. It means that A40 has some y coordinate, but x coordinate is different, so it is not on the curve, and hence so t-shirt cannot reach seat A40. And that's all for this question.